The Chapter 2 project is called Describing Data from Popular Sources. We're going to use MyStatLab and StatCrunch to work through this project today. Make sure that you have MyStatLab open, and you'll see here on the left side menu StatCrunch is available. So we're going to click Open StatCrunch. We're going to view the data sets from the textbook. And since this is the Chapter 2 project, we're going to select the options under Chapter 2. You can see there are example data sets and exercise sets. So we're going to the exercise sets, MLB parks for Major League ballparks. And here we find it. Click to select. And we have 29 different cities in the United States. We have elevations of those ballparks. We're going to concentrate on elevation, so we won't need the slug percentage column. Part A is asking us to use these 29 elevations to construct a dot plot. So if you scan down these numbers, these are elevations in feet, you can see that 10 is the lowest elevation, while 5,277 is the largest. So keep in mind that your dot plot needs to accommodate all of these elevations, not just some of them. So you will need to choose a scale to accommodate numbers from 0 to 5,277. All right, so make sure that your scale will accommodate all of these values, or your dot plot will not be complete. So I'm going to switch the screens and just show you quickly how you're going to construct this dot plot. We'll need one vertical line for frequency, and we'll need a horizontal line for the elevations of all of the ballparks. Now make sure that you label this axis. We should also have a title for the dot plot. Don't write title goes here, okay? That's just a reminder to include a title. And also the same for label the axis. What are the numbers actually representing that we are about to put on our dot plot? That's what your label should be about. And F represents frequency. So if our highest elevation was 5,277 feet, we need to make sure that we're going at least to 5,277. Okay, and then that scale is up to you if you want to count by hundreds in between or thousands. Break it down somehow, but space it evenly. And in order to accommodate numbers up to 5,200, be sure that you're using probably the full length of your paper, or it's going to be difficult to fit all of the numbers on there that you need. So this is just a general idea of what the dot plot is going to look like. And then we'll go back and look at the actual numbers. Like 160 is the elevation for the Anaheim ballpark. So 160 we know is going to be a lot closer to 0 than it is 5,200. So you're going to have to put some markings to indicate what your scale is and numbers below. And 160 probably is somewhere closer to 0. But your dot plot may look a little different. It depends on what scale you're using. If you're counting by hundreds or thousands, just make sure you can accommodate all of the information from the data set. For part B, I'm going to show you how to use StatCrunch to collect the stats on these elevations. So we'll click Stat, Summary Stat, Column, and the column we want is elevation. Now we do want to find the mean, so I first click just one option, mean. Then I'm going to hold down the Control key and include variance, and see how that was added to the drop down. And then we want standard deviation. Bring this bar down a little bit to get median and range. So we have mean, variance, standard deviation, median, and range. Those are all of the stats we're looking for. So we can press compute. Now notice the box has all of the headings, all of the values. It would be fine to round off these values to the nearest whole number for your project. So instead of recreating this whole table by hand, you can simply copy and paste it to your Word document. So I'm going to highlight all of the values that are in the table and its title with my mouse and press Control-C to copy it, click on my Word document, Control-V to paste it. And there we have the document. And if you don't want your table in this particular location, you can click on this small box and move it somewhere else. You can also take the title and drag it lower or wherever you want to place it. Okay, so there are some tips to help you not have to recreate tables. You can simply copy and paste them. In Part C, you're going to use Chebyshev's rule and the empirical rule to describe the distribution of the data set. Now remember, this is the whole population. Our population are these 29 elevations. So we're going to count how many of those elevations actually fall within 1, 2, and 3 standard deviations of the mean. So in order to do this, you might find it helpful to sort the data from the smallest to the largest values. And you can do this by clicking on the Data tab, and Sort is almost near the end. We want the elevation column, and we do want ascending order, and that's already the default. Compute, and you can see that a new column has been made. So from 10 to 5277. Now 10 does not go with Anaheim. Just keep that in mind. All that this column is telling us is the lowest to the highest elevation. But that will help you go ahead and maybe even double check your dot plot to make sure you haven't forgotten any values. But it will make counting a lot easier for you to determine how many of these measurements fall within 1, 2, and 3 standard deviations of the mean. So I'm going to move this table just out of the way a little bit. And if I have a standard deviation of 972.6, I'm calling that 973. So 973 is going to be added to the mean of 559. And that tells me what the numerical value would be, 1 standard deviation to the right of the mean. If I start with 559 and subtract 973, that tells me what the x value is, or the elevation, 1 standard deviation to the left of the mean. Now notice that's going to be a negative number, and we're not going to have any negative elevations if you look down this list. All right, we have nothing that's below sea level. So we won't need to go beyond 1 standard deviation to the left of the mean, because those negative numbers don't make any sense for our data set. Once you have the count, that is how many of these elevations fall between the mean and the first standard deviation, you're going to count how many, but don't forget to divide by 29, because there are 29 total elevations. That will give you a decimal, multiply by 100, and you will then have what percent of your data falls within 1 standard deviation of the mean. And you do something similar, count how many fall within 2 standard deviations, divide by 29, multiply by 100, and you will have your percentage. Then you can compare your percentage with Chebyshev's and the empirical rule. In Part D, we're going to be using StatCrunch to generate a random sample from our data set. So we're going to follow these bullets and create a sample. So the first thing we need to do, we already have StatCrunch open, we've got the ballparks, so we go to the Data tab. And now we're going to look at Sample, about halfway down. We want the elevation. We want 10 for the sample size. So we're all going to generate a random sample of just 10 of these ballparks or 10 elevations. We only need one sample. Everything else is set to a default. Leave those. Compute. Now I'll move this column out of the way. I have to reveal the ballparks. Here they are. So you can see we have 10 randomly chosen elevations. With this new set of data, notice it's called sample elevation. We can move this bar over, and now you can see the whole heading, sample elevation. So with these 10 elevations, we are now going to recalculate the mean, variance, standard deviation, median, and range. So I'm going to go to Stat, Summary Stat, Columns, but this time we don't want elevation, we want our sample elevation. So make sure you're choosing the correct column, sample elevation. And we'll first click Mean, then hold Control, choose Variance, Standard Deviation, drag the bar down so you find Median, drag down some more until you find, where is it, Range, there we go, and Compute. So now we have another table of information, but it is called sample elevation, so you can keep track of all of these different tables that we've generated. And you can generate them all like I've done just now, and then copy paste them to your Word document, or you can copy and paste them as you're writing your report. It's up to you. So in order to copy this to my report, remember I'm just going to select it by dragging my mouse and highlighting all that information. Control C, find my Word document. So make sure that you are putting your mouse away from the other columns so that they don't mesh together. Control V, and there it is pasted, Summary Stats. But you'll be able to keep track which is which because you do have the titles also included here for which column of data this is. So you should be able to keep track of that. Now for Part F, you're going to be using this sample elevation data to help you make your count. You're only using these 10 elevations now, and you're going to redo your count using the new mean and standard deviation just for your random sample. So I'm starting with a mean, and I'll round these to the nearest whole number, 544, and then I would add 380 to know what the first measurement value or first elevation value for one standard deviation to the right of the mean. Then I would take the mean and subtract the standard deviation to find out what the measurement is or the elevation for one standard deviation to the left of the mean. Now 544 minus 380, that's still going to be a positive number. So I will be able to continue to 2 standard deviations to the left. Make sure that once you get your count, you're dividing by 10 this time because you only have 10 in your sample. And then convert that decimal to a percentage by multiplying by 100. You can then compare your percentages with Chebyshev's and the empirical rules percentages. And that's what you're going to be doing to finish up Part F. The final part of the project is Part G, and Part G is a discussion. So by discussion, I mean just a few sentences to talk about the difference between the symbols that you're using that represent sample mean versus population mean. So there are different Greek symbols or other symbols that are used to separate sample from population. Do include what the symbols are and what they represent. So this should be just a few sentences in length. I hope you find this tutorial helpful with your Chapter 2 project.